Okay, we're going to be starting a new playlist on moments, and this is going to be a question from October 2022. So you can pause the video and try the question yourself. If you want to go to the mark scheme or you want to see the examiner report, you can go to the end of the video and you will see the mark scheme and examiner report. Okay, so without further ado, let's do this question. Okay. It says, a woman supports a stationary wheelbarrow by exerting an upward force P on the handles, and upward force R from the ground acts on the wheel as shown. The center of gravity of the wheel is marked on the diagram. Well, the first point that I want to highlight here is this right over here. The woman supports a woman supports a stationary wheelbarrow. Stationary means that your wheelbarrow is in static equilibrium. Basically, it's in equilibrium. Okay, which means that the moments due to force P and R are balanced. So they both have the same moment, because here we have the anti-clockwise moment. This will be clockwise and this will be anti-clockwise. So this is the clockwise and this is the anti-clockwise moment. So both of them will be the same, so your wheelbarrow will be stationary. Okay, now we know that moment is equals to force times perpendicular distance. Okay, now I'm going to explain it like this, right? So we have force R here times distance. This is the distance. Let's call it dr. Distance dr is equals to the force P times distance p. Distance p. Now you can see that this distance p is greater and this distance r is smaller. Now for them to be equal, have the same moment, your force P must be smaller and your force R must be bigger, so that the moments are balanced. You know, when forces are smaller, we increase the distance to make sure that we balance the moments. Okay, so let me just write it down. So here's your answer. Distance from G is greater for force P. So for the same moment, force P must be smaller. Okay, so this is going to give you 1 mark, 2nd mark, and then 3rd mark. Okay, that's how you do this type of question. I think the tricky thing about this is just wording it the right way. Other than that, it's not that hard of a question. Now let's look at this one. So here it says the horizontal distance between the center of the wheel and the handles is 1.5 meters. The magnitudes P and R are shown are as shown. So here's going to be P and R if both the forces. Determine the horizontal distance between the center of gravity of the wheelbarrow and the center of the wheel. So we're going to have the center of gravity somewhere. Let's say we don't know where it is exactly. Let's say it could be somewhere here. Okay, this is center of gravity G, and this is the center of the wheel, and we have to find this distance right over here. Okay, we can call this distance x. Okay, and then this distance right over here is gonna be 1.5 minus x. We can say then anti-clockwise moment is equals to clockwise moment. So there's gonna be this moment, and then this will be anti-clockwise, and this will be clockwise. Okay, then you can say 80 times 1.5 minus x is equals to 320 x. So you're going to solve that out, and then you're going to solve for x. So here's the value of x. It's going to be 0.3 meters. Okay. So that's the answer to this question. You can just go through it, and I'll show you the examiner report and mark scheme. So here is the examiner report and the mark scheme. You can just go through it.